So hello everyone and welcome to our discussion today. Today we'll be discussing about determination of fertilizer rates. So these are common questions in agriculture, that is soil fertility 2, topic 1 form 2 work. And I'm hoping that all of you who have difficulties in calculating fertilizer rates, at the end of this session you'll be able to do that without any assistance. So I'm here to make it easy for you. I'm here to make it very easy and understandable. So stick around until the end and be able to learn something. So before I say anything, I'm Mwalimu Jacob again. I'll be taking you through agriculture and biology sessions. And I hope you guys will learn something and enjoy our sessions. So to the topic today, determination of fertilizer rates. So when we talk of determination of fertilizer rates, first of all, you have to understand two concepts. We have two concepts that are involved as far as determination of fertilizer rates is concerned. Number one, you need to understand what a fertilizer grade is. So you need to understand what a fertilizer grade is. And when you talk of a fertilizer grade, this is simply, it shows the total amount. It shows the total amount of the three primary macronutrients contained in a fertilizer. So this one shows the amounts of the three primary macronutrients. And what are these three primary macronutrients? We have nitrogen, we have phosphorus, and we have potassium. So that is a fertilizer grade. For example, if we say in a 100 kg of NPK, for example, there is 20 kgs of nitrogen, then that becomes a fertilizer grade. You also need to understand what a fertilizer ratio is. You need to understand what a fertilizer ratio is. And whenever we talk of a ratio, it means we are comparing the proportions of these fertilizer nutrients or macronutrients in a fertilizer. So when you talk of fertilizer ratio, this one shows the relative proportions. It shows the relative proportion of the three primary macronutrients. So in fertilizer grade, we are looking at the amount, ziko ngapi. And now when you talk of the fertilizer ratio, we are looking at the ratios in which they are found. For example, if we can come back to our question here, you'll find that in this NPK fertilizer bag, 15 to 10 to 5, now this becomes a ratio. Then later on, as we'll be discussing, we'll now be calculating the grades of this particular fertilizer. So if you can understand this one, then the question becomes very easy. So let's now try out the question. Yes, and by the way, if you are new here, make sure you subscribe, make sure you follow us so that the coming lessons you don't miss. So Mwalimu Jacob everywhere, YouTube Mwalimu Jacob, Facebook Mwalimu Jacob, TikTok Mwalimu Jacob everywhere. So you'll be able to search and find these sessions free of charge, by the way. So question, a farmer was advised to apply 240 kilograms per hectare of NPK fertilizer 15-10-5 on his piece of land measuring 400 meters by 300 meters during top dressing. So the question asks, what do the figures 15-10-5 stand for? What do the figures 15-10 and 5 stand for? So before you can even look at anything else here, you need to understand what do these three figures represent. And now we already talked about it. 15 represents nitrogen, 10 represents the amount of phosphorus, and 5 represents the amount of potassium. But we all know these elements cannot be absorbed the way they are. So they are found in different forms. So to respond to such a question, you'll say 15 stands for 15% N, and we know N stands for nitrogen. Then 10 stands for 10% P2O5. So in this case, phosphorus will be found in that particular bag as phosphorus pentoxide. So we don't say 10% P, but we say 10% P2O5. This is phosphorus pentoxide. Then now 5 will stands for 5%, not K but K2O. This is potassium oxide. So this is a form in which now this potassium oxide will be found in such fertilizer bags. So these ones are what the three figures or three letters or three numericals stand for. So 15 stands for 15% N, 10 stands for 10% P2O5, and 5 stands for 5% K2O. I guess it's understandable. If you have a question, make sure you comment it there for me to see. So that was part A. So let's look at part B. Part B. So part B may question you or ask you to determine now the fertilizer grade. So determine or calculate the amount of each primary macronutrients that were applied on his piece of land. So calculate the amount of each primary macronutrients that were applied on his piece of land. And in most cases, this question may carry up to 6 marks. So these are 3 marks again. So let's try it out. So we know the primary macronutrients are 3. We have nitrogen, phosphorus, and potassium. But before we can even find the amount of each primary macronutrients, we will first of all read the question again. You will find that this farmer was advised to apply 240 kilograms per hectare. So in this case, the farmer is applying 240 kgs per hectare. But what is the area of land? This farmer has a piece of land measuring 400 meters by 300 meters. It means if he wants to apply this fertilizer on this piece of land, then surely it will not be 240. It will be something else, either bigger or smaller than 240. So we need to find that amount that will be applied on this piece of land so that it becomes very easy to calculate the amount of these ones that were applied on his, because now his here refers to 400 meters by 300 meters. So the first step will be area of land. So what is the area of land here? Will be 400 meters by 300 meters. So this one will give you 120,000 square meters. So the area of land of this farmer is 120,000 square meters. So you'll ask yourself, if 1 hectare is an equivalent of 10,000 square meters, how many hectares are these ones? What about 120,000 square meters? So this one will be 1 hectare times 120,000 square meters over 10,000 square meters. So this one will give you 12 hectares. So it means the area of land in question is 12 meters and not 1 hectare. So it means we'll be able to calculate the amount of nitrogen that was applied on 1 hectare, then equate it to 12 hectares to find the amount that was applied on his piece of land. The same to phosphorus, the same to potassium. So the area of land is 12. So I hope you are writing. So we can place it somewhere so that you don't forget. So the area is 12 hectares. So we'll start with nitrogen. So in this case, we are assuming this bag has a total of the composition is 100%. But out of this 100%, we have 15% from our part A being nitrogen. So it means for every 100 kilograms of NPK, there is 15 kilograms of nitrogen from our part A, if you can remember. So if 100 kilograms of NPK carries 15 kilograms of nitrogen, what about 240? What about 240 kilograms of NPK. So you will ask yourself this question. So it will be 240 kilograms of NPK multiplied by 15 kilograms of N divided by 100 kilograms of NPK. So that again, in agriculture, we don't cross out. So you just do the sum the way it is without crossing out. So if you cross out, that is wrong. So 240 times 15 divided by 100. I hope you are doing the calculation with me. How much? So I will also consult my calculator. So this one gives me about 36 kilograms of nitrogen per hectare. So that is 36 kilograms of nitrogen per hectare. But remember, the area of land in question is 12 hectares. So it will be, if 36 kilograms are supplied in 1 hectare, what about now the area, which is 12 hectare? This farm will supply how much? So it will be 36 kilograms of N multiplied by 12 ha divided by 1 hectare. So this will be 36 by 12. How much again? That's around 432 kilograms of N. So this farmer, nitrogen alone, this farm will need 432 kilograms of nitrogen to be supplied in the entire area, which is 12 hectares. So that is for nitrogen. We can still do the same for phosphorus. So phosphorus, for every 100 kilograms of nitrogen, there is 10 kilograms of phosphorus. So it will be 100 kilograms of NPK supplies 10 kilograms of phosphorus pentoxide. What about 240 kilograms of NPK? So ask yourself the same question again. So this one will be 240 kilograms of NPK times 10 kilograms of P2O5 divided by 100 kilograms of NPK. So this will be how much? This is around 24. So 24 kilograms of P2O5 per hectare. 24 kilograms of P2O5 per hectare, but still this is per hectare. So we need to find the amount of phosphorus that will be required to be supplied in this particular area of land, which is 12 hectares. So it will be 24 kilograms are supplied in 1 hectare. What about 12 hectares? So this implies that 24 kilograms times 12 divided by 1 hectare. So that is how much? Again, that's around 288 kilograms of P2O5. So the farmer will require 288 kilograms of P2O5. We can still do the same for potassium. I'm sorry, my space is limited, but I hope you are following. Sorry. So you can do the same for potassium. We ask ourselves the same question. So if 100 kilograms of NPK carries 5 kilograms of K2O, standing for potassium oxide, what about 240 that this farmer was devised to apply? So what about 240? So how much, if this farmer applies to 40, how much will his supply of potassium per hectare? So it will be 240 kgs NPK times 5 kgs K2O divided by 100 kgs NPK. So this one will be how much? So 240 times 5 divided by 100, that is around 12, if I'm not wrong. So you supply 12 kgs of K2O per hectare, So per hectare, K2O 12, if this farm applies to 40 of this particular ratio. So again, the number or the area in question is 12 hectares. So we'll calculate if this is for 1 hectare, how much will he require for 12 hectares? So it will be 12 kilograms of K2O being supplied to 1 hectare. What about 12 hectare? This farm will need how much? So this will be 12 kilograms of K2O times 12 divided by 1 hectare. So that is how much? So 12 times 12 divided by 1 becomes 144. 144 kilograms of K2O. So in this particular area, this farm will supply 144 kilograms of K2O. I hope this one makes it easy. And again, a question may ask you, so keep this value somewhere. Again, the question may ask you, now part C. Part C may ask you, calculate the amount of filler material that may be carried within the fertilizer. So you'll realize that different fertilizer companies use some materials to fill up the bags. These materials can be sand, this material can be sticks, this material can be leaves, and so on and so forth. So you realize the entire bag is not carrying only the fertilizer elements, it's also carrying the filler material. So if you want to calculate the amount of filler material, it means you just take the total amount of the fertilizer, you subtract the totals of the primary macronutrients. So in this case, the total of the fertilizer was 240 kilograms of NPK. And now we are using the figures that this one supplied to 40, that is per hectare. So 240 minus the amount of nitrogen per hectare was, what was the value? The number of nitrogen, kilograms of nitrogen was 36. We will add to phosphorus. Phosphorus was 24, if I'm not wrong. Then, of course, potassium was 12 kgs. So this one will imply that 240 kilograms minus 36 plus 34 plus 12, 36 plus 24, this is 60, plus 12, this is 72. So this is minus 72 kilograms. So it will be 240 minus 72. That is, no, I'm sorry. It will be 240, 72, 3, 1, 8, then 1. This is 6. 168. So you realize this fertilizer was carrying 168 kilograms of filler materials. So up to that juncture, I think we are done with this question. So if you have not understood better, you can still be able to reach me using that particular number. You can WhatsApp, you can call for a cheap or a coffee's price. So again, if you are new here, make sure you subscribe so that you don't miss subsequent lessons. As I said, I will be revising biology and agriculture questions both for the 844 system and for the CBE curriculum or system. So at that juncture, I say have a blessed day, and I hope this concept will start playing a role in the life of each and every one of us. Shalom.